Once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to actually go a notch higher in calculating or finding the equation of the tangent to a curve. And this one, we are specifically to find the equation of the tangent to the curve. This is the curve at the point P where x is equals to 3. We are going to do several things. First of all, we must know some facts. And one of the major facts is that the gradient of the curve is equals to the gradient of the tangent at the point of contact. What is a tangent? This one is actually a cubic function. And if you are to sketch a graph, it will kind of look like this. We are going to have a graph that looks like that. And let's say this is where 3 is. At the point x is equals to 3. Let's say this is the point we are talking about. As the graph or the curve moves, there will be a straight line that touches the curve at that very point only once. So a tangent is a line that touches a curve only once as it moves. It's a straight line. So in this case now, we are talking about the gradient of the curve, which is equal to the gradient of the tangent at this particular point of contact. You realize that the gradient of the curve keeps changing. For example, at this point, the gradient is 0 because the tangent is horizontal. But at this point, we will find the gradient. Now, if the equation we have or the function we have, it does not require to be done anything, it is finalized. So we straight go to dy dx, or we should now attempt to calculate the gradient of the curve. Now the gradient of the curve is 3 times 1, which is 3x squared, now we know, minus 2 times 3, which is minus 6x, and that is it. Because this one is a constant, it's going to die. So at x is equals to 3, at the point where x is equals to 3, then the gradient, which happens to be now the dy dx, becomes 3 squared minus 6 multiplied by 3. This one is 9 times 3, which is 27, minus 18, which is 9. So the gradient of the curve at x is equals to 3 is 9. And so is the gradient of the tangent. Now, if we know this, then we are going to find the equation of the straight line. But before we can even do that, we are having point P whose coordinate is 3. Do we even know the value of y? For us to know the full coordinates of the point P, we substitute 3 in the function. So we have y is equals to 3 cubed minus 3 squared plus 2, whereby this is 27 minus 27 plus 2. So you can already see that y is equals to 2. So the coordinates of point P is 3, 2. Just in case, we will require to use the value of y at point P. Now, having done that, we all know that the equation of a straight line is given by the equation which is generally known as y is equals to mx plus c. And you know this is obviously the gradient, and c is the y-intercept. Now, Of course, if C is the y-axis intercept, we would now want to find out what could be the equation of this tangent. We don't know the value of y, but at least we know the gradient. Remember, the gradient is 9 because, as we have understood in the slides, the gradient of the curve is equals to the gradient of the tangent at the very point of contact. That means what? If the general equation is y is equals to mx plus c, and at point P, y is 2, then 2 is going to be 9, because 9 is the gradient as m, and at point P, x is 3 plus c. What does this mean? We are going to have 2 is equals to 27 plus c. If you want to make c the subject, you're going to find c is equals to 2 minus 27, and in this case, c is equals to minus 25. In other words, now, having found all the parameters or all the details, we can now finally write the equation of the tangent as y is equals to 9x minus 25. Remember, y keeps changing along the straight line, x keeps changing along the same straight line, but the gradient is constant because it's a straight line, and the y-intercept has been identified. So, ladies and gentlemen, that is now the equation of the tangent to the curve at the point where x is equals to 3. Thank you, and let us meet in the next video.